Hello, guys. So this is a new chapter, and it's called number patterns. And I don't know if I should say unfortunately or fortunately, but then this will be the only video, that I'll record under this, you know, under this chapter. And in fact, there will be two videos. It will be this one, and one where I'll just go take a particular question from a question paper and then solve it with you guys. So let's start. Last year in grade 10 y'all did linear sequences, you know um and of course, I should say that a sequence, is a set of numbers of variables that follow each other in a particular order. You know what I'm saying? Yeah. And before we get into, like, of course you already see the question here, find a general formula. But before we get into that, let me discuss something. The standard form of your formula for a linear sequence would be something like Tn is equals to An plus C. So for a linear function, for a linear sequence, it is something like this, of which I will identify these. So this is your term value. This right here is your term number, and then this right here is just your constant, um your constant, which of course you get it from subtracting the first term with the common difference. And as for the common difference, this is the common difference. So just know all of these things in case you did forget them. Try to know them again and remember them, because it does really help knowing what is what. In fact, in these questions, we will just tell you that you have a particular term number, particular term value. Cool. Cool. Let's get into this problems. Let's start solving these problems. And I'll say, like, some math topics, I would say, trying to explain them, you would find yourself trying to beat around the bushes a lot. But you'll see that your life gets way much easier the moment you start practicing with some problems, solving some problems. Like we have here, they say, so find the general formula, which is the rule that gives us the numbers that follows these numbers, and so on and so on. So let's get into it. If you have something like this, the first thing you have to do is to find your difference, which of course is your common difference. You can just say, for example, here 16 minus 13. So also something I didn't say, to find your common difference, from grade 10, of course, you just say d I ti minus ti minus 1 equals to, this is your common difference, right? So in this case, I will take maybe t2 and I'll minus t1 and I'll get my d. And of course here this is just 2 minus 1, then I'll get my common difference. Yeah, so let's get into it. I say 16 minus 13, I get 3. I can just be lazy since I know that this is a linear function. Damn, actually I made a big mistake here. I believe the number here should be 19. Yeah. So yeah, the number that follows, I know it's gonna be 3. It's gonna be 3 without even thinking about it. I already know this. Why? Because this is a linear function or linear sequence. In a linear sequence, there we have the common difference there. The difference between the consecutive term values are the same, yep. So now you have your common difference. You now know that you have something like this. Tn is equals to 3n plus what? Plus c, right? Remember, the last thing you have to find is c. After you have found your c, you are done, right? So how do you find your c? You can take, believe me, you can take any term number, with its corresponding term value, any of them. You know what I'm saying? There's no rule that says use the first, use the second. It's your choice. Just to show my freedom here, I'm gonna use term number 4, right? So I'm gonna have 3 4 plus c, and then what is the term value corresponding to term number 4? It's 22, right? 22 right here. This is term 1, term 2, term 3, term 4, right? The term value corresponding to term number 4 is 22. Now I'm just doing my math. It's gonna be 22. Of course, this is 12, so minus 12 is equals to c, and then that c is gonna be 10, I believe. Therefore your general formula is gonna be Tn is equals to 3n plus 10. Right, let's start right with term number 2. So term number 2, it's gonna be 3 times 2 plus 10. 3 times 2 is 6, times 10, that's 16, and there we go, we know it. So in this question, usually you'll get some crazy question asking you about term number 100. If you want to find term number 100, what's the term value corresponding to term number 100, you'll just say T100 is equals to 3 into 100 plus 10, and that will be what? That will be 300 and what? 310, and then you are done, literally. You know what I'm saying? Let's do the second one. The second one is quite interesting in a sense that we have negative values. So here, of course, you will say minus 15 minus 10, which, assuming you're doing it by head, plus 10, and this is minus 5, right? And of course, I know it has to be the same throughout my problems. I can test it with term number 4 and term number 3. That will be minus 25 minus 20. I'm getting negative 5. So that means what? That means I'm still on the right road. You know what I'm saying? For real. Then the next thing, I have my common difference right now. I can just say I have Tn equals to minus 5 and plus what? Plus c. Now, what's the next thing? It's for me to pick any term value of my own. You know what I'm saying? Like, literally, there's no one putting a gun on my head telling me to choose a particular one. I can choose my own, So last time I was using term number 3, let me use term number 4. Last time I was using term number 4, let me use term number 3 right now. Cool. So I'm gonna take term number 3, ne? That means I'll have 5 into 3 plus c, and this right here I'll have minus 20. Then I have my minus 20. I'm gonna transpose the product here, which is gonna be minus 15, but when it comes this side, it's gonna be a positive 15, right? Then I have what? I have minus, I have c. Then my c will be what? Minus 5. What does that mean? It means, therefore, Tn equals minus 5 and minus 5, right? Let me test it out. Which number should I go with? Let me try it for term number 2. Now, minus 5 into 2 minus 5, right? What am I getting? I'm getting a minus 15. That means my general formula is correct. It works. And again, they give you some crazy question about term number 100. You can just go on and say T100 will be minus 5 into 100 minus 5. which the answer will be minus 505. You know what I'm saying? Then bang, you are done. These questions under linear, they are kind of easy, lightweight. But let's try to spice them up. Here, it's not really spicing it up in any way. Here you can just use your calculator, but of course, I believe a calculator will be enough here. But of course, if you want to show your workings, you will see this is term number 2, term number 3. We are looking for the missing terms, which is term number 2 and term number 3. So what? So you go here, you like T3, or let's start T2. T2 equals to 1 minus 5 into 2. So you already know that's gonna be 1 minus what? Minus 10, which is what? Which is minus 9. You go here, you have minus 9, right? You go again, you like T. Actually, this is term number 4, not term number 3. It's 1, 2, 3, 4, and 5, right? So now you go term number 4. Term number 4 equals to what? 1 minus 5 into what? Into 4, right? You get 1 minus 20 and you get 19, negative 19, right? Then bang, you are basically done. Ne? Maybe just let me see if it works. And the general formula they gave here, I'll say 1 minus 5 into what? Into 3, and I'm getting minus 14. So you see, just something light, something that is quite interesting and is a little bit fun is this problem that we have here. I spiced it up a little bit. As you can see, we have to find the missing term and the general formula, right? So this is term number 1, number 2, number 3, number 4, number 5. Do you know what I'm saying? But of course, this is a sequence, so it continues, and they say let us find the missing terms, so this one is quite easy as well. All I'm gonna say is don't overthink it. Use what you know to get what you do not know, right? So let me say maybe this is X. Different color would help. This is X, ne? So for me to find my X, I can do what? I can say I know the difference has to be the same. I'll say D for difference, ne? It has to be the same. There's a linear sequence, ne? So now what? I go again. Damn it, man. Why you do this to me, bro? Yeah, these tablets. Yeah, cool. So now I can say X minus what? Minus 6. It's gonna give me D, right? And 24 minus X, it has to give me D as well. Now it looks like I have simultaneous equation. That's equation 1, that's equation 2. I can say D equals D, and therefore I have X minus 6 equals to 24 minus X. I transpose the X, so I have X plus X. I have 24 plus 6. I have 2X equals 30. I'm running out of space, but I have X equals to what? 15. So I know that X equals what? Equals 15. Nah. But now what is D? D, remember, I did say X minus 6 equals D. So X, which is 15, 15 minus 6 equals what? Equals to 9. And since there's a linear thing, I know that all these D's are going to be 9. Yep. So yeah, I'm done. But I can do it the same thing with here as well. Why? You will still find, or you will still get to the same answer as I did. Perhaps let me do it. For 9, I'll just say, for Y, I'll say 42 minus Y equals D. Y minus 24 equals D. And then what? Okay. and then what? I have d equals d, d equals d. That means 42 minus y equals y minus 42. Damn. See, it's very easy to make mistakes, fellas. Minus 24, not 42. So yeah, now I'm transposing. I'm gonna have 42 plus 24 equals 2y. I have 2y. I have 66. Divide. I have y equals to 33. So y will be what? Let me use a red. Y equals to 33. And then I can just go again and be like 42 minus 33. How much is that? I borrow from here, so I have 12 and I have 3. And then of course 12 minus 3 is gonna be 9. 3 minus 3, that's 0. So I'm still getting 9. It doesn't matter whether I use x or y, I'm still getting those values that are the same. My common difference is the same, and yeah, and I already have the missing terms. Now what? Let me now find the general term, which of course will not be tough thing. Yeah, so I have Tn equals to 9n plus c. Let me just use 6 now. I'm gonna use term number 1. I'll say 9 into 1, and this is c, so this will be 6. Then now I have 6 minus 9, this will be c, then this will be minus 3. Therefore Tn equals to what? Equals to 9n minus 3. You know what I'm saying? So for real, we're done. See, these questions, they're not so difficult. All I can say is try not to overthink them. Use what you know to get what you do not know. And something that I wanna show you, something that I'd wanna show you is this. C, you can find it by saying T1 minus D. Ne? Like in this case, you will say 6 minus 9. You will get what? Minus 3. Let's go back to other problems as well. Here, for if I want C, let me use red. So C will be what? T1 minus D. That will be T1, which is minus 4, minus, what is my D? Minus 5, And then how much is that gonna be? Minus 4 plus 5, that is 1, right? You see that? Give it a last try. Let's give it a last try with number A. C equals to what? C equals T1 minus D. T1 is 13 minus 3, which is 10. And there we go, 10. So that's something you all should remember. Try not to forget it, and your life will be, your life won't be miserable. Cool. Yeah. Yeah. I think now we're gonna cook up some. Damn, I'm trying to pause this video. Damn. What's going on? There we go. Cool. Yeah. Yeah. So now for quadratic sequence, it's a little bit different from linear sequences. Quadratic sequences, something that I would say you must take note of. This right here is the standard form of your general formula. What it looks like, it sort of looks the same as ax squared plus bx plus c. No difference. This all the same thing. And here, when trying to find the general formula for your quadratic sequence, these are the most important things, Without these, I am telling you, I do not know how you will be able to find your general formula. But without remembering these or without knowing these things, your life is gonna be way hard. You know what I'm saying? So let's try to apply these into this problem where I have a problem there. I'm sure so for quadratic sequences, ne, you're gonna find two differences. As you can see here, I have the second difference and I have the first difference, and of course this is term one. So what you will do is that you will find the first difference, which, let's do it right now. And your first difference, you're gonna have different numbers. The numbers are not gonna be the same. Right here I have 3, 6 minus 3. Here I have 4 from 10 minus 6, and then here I have 5 from 15 minus 10. I have 6 from 21 minus 15. Yeah? Then from here you realize that man, it's just the same. Your second difference, they have to be the same. If your second differences are not all the same, there is something wrong either with the pattern, or perhaps the pattern, there is nothing wrong with the pattern. You happen to not be dealing with a quadratic pattern. We have other patterns, which of course are beyond the scope of grade 11. Yeah. Oh, one, no, those are series. But yeah, quadratic sequences. So cool stuff. Let me see what we can do. Now we're going to apply these things. Okay? We say first difference. So we have, this is right here, this is all of these are the first differences. These are all your first differences, and right here you have your what? You have your second, you have your second differences. So now we're going to do what? Ne? Look at second difference. Second difference is equals to 2a. Ne? So we're gonna come here and we will say 2a equals what? Equals 1. Ne? And therefore a equals what? Equals 2 half 1 over 2. Ne? Now we're gonna go to the first difference. The first difference, it says 3a plus b equals what? Equals to the first difference, which in this case we're gonna use 3. So also, like when we are solving these things, the numbers which we are more interested on are these ones. Ne? Our interest is those numbers. You see here I used the one from here, and now look, I'm using this 3. You know what I'm saying? And I'm gonna use this 3 again, on the last one. So here of course I'll have it's 3 into 1 over 2 plus b equals 3. Now I'll have b equals 3 minus 3 over 2, which is gonna be 6 over 2 minus 3 over 2. That will be what? That will be 3 over 2. Damn, let me see. 3 minus 3 over 2. Yep, I'm alright. I am alright. So yeah, and then the last thing for me to find is c. So c, I'm just gonna say a plus b plus c equals what? Equals to t1, which t1 in this case is 3. So 1 over 2 plus 3 over 2 plus c equals what? Equals 3. So what does that mean for me? I have 4 over 2 plus c equals 3. And then I'm gonna have c, this is gonna be 2, 3, then c equals 3 minus 2, which is 1. Right? So I'm done. What does that mean for me? Therefore, Tn equals what? Tn equals to a, which is half n squared, and then b 3 over 2 n, and then c, which is 1. and then I'm done. You know what I'm saying? Yeah. So that's just how we do it. Try to remember those numbers. The most important ones are these things here. T1, first difference, second difference. Remember all of those by heart and all of that. Ne? Cool. I think this will be the last. Let's see what we can get from these problems. So here they say given Tn, try to find, you know what I'm saying? Given Tn, let us try to find T9. That one is very easy. You just come here, 4 into what? 9 squared plus 5 into 9 plus 10. What does that gives you? Go straight to your calculator. 9 squared plus 5 times 9 plus 10. 3, 7, 9. That is your answer, and you are done. Ne? So this ones are gonna be a bit interesting, Yana. Actually, I wish I would have maybe spiced it up, though. You know what I'm saying? Like the last question we did under like linear sequences. You know what I'm saying? Let me see. Find the general formula for the quadratic sequence above. You know what I'm saying. I think you don't know what I'm saying, ne? I think I have something interesting, ne? Let me rewrite this question. I'm gonna try something cool. I'm gonna try something cool. So I'm gonna erase this one. I do not have it. I don't know what it is. I don't know what it is. Kappa, will that actually help? No, it will not help. It will not help. Okay, cool. I will do this maybe off the record and then try to come up with something. So yeah, let's just do this one. So they say find the next two terms. For that to be easy, you're gonna have to do your first differences. You're gonna have to do your first differences. So 27 minus 16. The answer is 11. 42 minus 27, that is 15. 61 minus 42, that is 19. Cool. So I'm gonna do something interesting. Here you already see this is 4, this is 4, and of course you see that there will be a 4 here. That means what? You have 23, and you will have 4 here. That means what? That means here you will have 27, right? Yeah, the difference is just always 4. 27 minus 23, 4. 23 minus 19, 4. You know what I'm saying? Cool. So there, to find this term, 1, 2, 3, 4, 5, 6. To find term number 5, this is what we do. We go say 61 plus what? Maybe let me start from here. We have 16, term 1. Term 1, if I add 11, what do I get? I get 27, which is term 2, ne? Term 2, if I add 15 plus 15, what do I get? I get 42, which is the next term. And then I'm like 42 plus what? Plus 19. What do I get? 61. So the next one, what does that mean? It means I'm gonna say plus 61. Let me just say equals to, and then 61 plus 23. What does that give me? It gives me 84. You know what I'm saying? Then the next one, I'll say 84 plus 27. What does that gives me? 111. Done and dusted. You know what I'm saying? So that's how it goes. That's how you deal with these things. Let's just find the general formula. We're gonna start with 2a, which is equals to 4. Then a equals to 2, And then we have 3a plus b equals what? Equals 11. That means 3 into 2 plus b equals 11. And then you have b equals 11 minus 6, right? So 11 minus 6, I think that's gonna be 7. It has to be 7, is it? No, it have to be 5. It's gonna be 5. Let me just try it. 11 minus 6. Yes, that's 5. So now the last one, I have a plus b plus c equals what? Equals term number 1, which is 16. And then I substitute now 2 plus 5 plus c, which I do not know. And then I have 7 plus c. 16c is 16 minus 7. That means c is what? Is 9. I will just give it a try just to make sure, you know what I'm saying. 9. And then when I'm done with that, I have found my general formula. I can say therefore Tn equals what? Equals 2n squared plus 5n plus what? Plus 9. Then bingo, I am done with this problem. And that is, that is something interesting, something nice, about this. I don't know what I'm saying. So I want to make a promise that I'm gonna try to find some interesting problem. I'm gonna try to spice it up, under quadratic questions. So I'm gonna find some question paper question, and then if I don't happen to find my kind of question, I'll try to come up with my own, and yeah. Good luck guys with this chapter, and see you in the next video.